Hello everyone, welcome to Pico Academy. We are happy to be here. I think there's nobody in the world who would be more happier than me. A couple of slight hiccups. I've had COVID for the last 2.5 weeks. I thankfully feel better today, and Phil put his back out over the weekend. What's the matter? Oh, my bottle, sorry. You can see my bottle top. I apologise. Yeah, so Phil had put his back out, but he's much better now, I think. We'll keep the old acupuncture going for him through the session. So anyway, a lot to get through, but before we do any of that, just a big welcome to customers of free distributors today. So Mount Equipment down there in Australia, I envy all of you for being, well, I guess you're getting towards the end of spring, coming into summer down under, so I wish you well with that. It's flipping freezing here this morning. We're about -1. And again, friends and customers of Garage Lube down in South Africa, similarly, you'll be looking forward to the warmth of summer on your back. And then up to Autotech up in Iceland, so, well, you'll know exactly what I'm talking about when it comes to cold. So welcome to all of you. We've got a lot to get through. And we've got a few videos tonight where we've brought in pieces from Steve Smith and Ben as well to look at. We do a parasitic drain later on, as well as looking at some EV testing. So huge amount to get through. This is the rough schedule. We'll have a break somewhere in the middle. So the first half is here, and then we come into somewhere in there. We'll have a break, so about an hour in, we'll have a break for sort of 10-15 minutes, then we'll come back to the certainly more complicated. So the first half really is the basics, getting started with Picoscope. So if some of you are watching and you've used Picoscope for a long time, by all means stay, watch it, use it as a refresher, but it will be the second half when we get into some more complex testing, systems testing as we call it. Okay. I think that's it from an intro point of view. Hopefully we won't have any skips being emptied or some such other scenarios today. So first job, if you haven't already, please download the new Picoscope Automotive app. And we are going to be showing you bits of that as we go through this evening. It is designed for new users, but equally as a kind of progress tool for more advanced users, so you can use the app to look at ways to test things alongside obviously working on your laptop or your PC, testing a component. And the beauty of the app, that is really now the app will replace any sort of catalogue that we used to have. So any new products, as we develop them, they'll be flashed into the app, will be the first place that you'll see them. As well, of course, we'll be sending that info through to distributors, and I'm sure it'll be on their websites as well, so you can download that either on the apps or on Google Play. So if you haven't already, yeah, get on and do that now, because you'd be able to have kind of look as we kind of go through the session. Okay, those of you who've watched it before know that I always have a starting thought idea. Clearly, there's no one smarter in the universe than our Yoda. But I think this is really important, actually, when we think about diagnostic process. You know, we do or we do not, but we don't try. So we always make sure that we do absolutely get to the root cause of the problem. And often, Picoscope is going to help you draw to the right conclusion. So just think about that. You know, we are absolutely doing, and everything that we show you today will be about root cause diagnostics, so you can see how a component is working in real time. So let's get into it. So what is Picoscope? For those of you who aren't aware already, it's a diagnostic oscilloscope. Effectively, we take any component within a vehicle. We start by talking about electronic components, and we connect directly into that, either that component or the wiring, and we pass it through our oscilloscope. That's the latest 4425A model oscilloscope. And through that, we pass it into our Picoscope 7 software, and we turn it into a waveform. And that, from a technical point of view, is how you could see and understand how a component is operating in real time. Excuse me, I have still got a little bit of a COVID cough. It's a pain in the, you could guess the rest. So yeah, our waveform, so anybody who isn't aware, our waveform is very simply voltage plotted against time. We plot that signal 400 million samples a second, which is a huge number. And as we start to look at systems later on, you'll see what that's important when we start to use Zoom. But it is very simple. It's exactly the same as we do as a multimeter, but plotted 400 million times on the screen. And actually, one of the first things Phil's going to show you today will be that very simple test. Okay, so what can we view with Picoscope? Well, three main types of signals. Most of what we're going to focus on today is going to be electrical systems. So anything from sensors right the way through to communication networks, and now, of course, working on electric vehicles. For those of you who've got the new Picoscope 7 software, you'd have noticed that we've got a lot of EV testing capability in there. And of course, it's the biggest part of what we see as the growth over the next few years as the world flips into full EV mode. We can always also look at pressure. So that's using our pressure transducer, the WPS 500. We've got a short video that Steve's put together for us on that. And then finally, NVH, so noise, vibration, harshness. We don't touch anything of NVH today, but some really great videos on our YouTube channel, and I'll show you where they are a little later on. So there are three types of signals. So let's just have a very quick look at an example. And this is how we capture a signal.
Just like all forms of mechanical diagnostics, the first step is to ask the customer about the problem. This is often, but not always, accompanied by a dashboard warning light.
So we've got a typical customer coming in with a fault code. And of course, you need a serial diagnostic tool alongside all the other tools in the toolbox, including Picoscope. So here we've got our two technicians, and we've got our what we would call normal technician, and then our aspirational Picoscope technician. Now this is where we would warn against being a part swapper. So you take your fault code, assume that that is the problem, replace the component, and then just reset and send back. Of course, the difference with the Picoscope technician is we're actually going to test that component before we remove it. So we've got a backpinning probe in there, and we're going to capture our waveform. So that's a fairly typical camshaft sensor waveform, a square-edged waveform.
Further, the Picoscope technician adjusted the wiring harness and found that the waveform was disrupted by moving the wires. After repairing the wires and retesting the sensor output, the fault code was cleared and the vehicle was returned to the customer. 2 days later, the technician's customer returned to the service department with the check engine light on again with the same fault code as before. This time, the technician successfully diagnosed the problem using the Picoscope and returned the vehicle to the customer again.
So yeah, it's a simplistic view in terms of where Picoscope fits in the diagnostic process, but it's an important point. You know, what we use in Picoscope for is to verify the fault that's causing the fault code. So we're going direct into component. We're not filtering that signal through an ECU. So we've got what we would call, you know, what is effectively true live data there that we're looking at. And actually, if we just take this example here, so we quite often get asked, well, you know, I don't need Picoscope because I've got live data on my scan tool. And look, there are times when live data is absolutely going to help you out. But if we just take this example of an accelerator pedal signal, look at the difference between the two. We've still got the two tracks of data, but what you see with the serial tool is quite blocky. It's very difficult to capture that kind of in real time. Whereas when we come down here and we're looking at the Pico, so we've got our 2 tracks, you can see how they operate against each other, and we can watch that. Also, the other big beauty of working with Picoscope is you're capturing that signal, and then you can add in another channel, look at another component. You could see how the two are working together, and go back to our example there on the diagnostic journey. If you've got an issue with a wiring loom and you do the wiggle test, if there's a fault, you will see it in the waveform. So actually getting down to root cause diagnostics is really, really important, and not having that data being filtered through an ECU. We're going to build on this as we go through the session, so you'll start to see kind of how we apply that live on the vehicles. So where to start? Well, you download our software. This is on www.picoauto.com. So that's there. And on there, as you will see, you've got the downloads. So you go into downloads and you can download that. So you don't actually need to have purchased Picoscope to download the software. You can run it in demo mode, and you can start to work out, how you're going to use Picoscope even before you brought the scope. So it's a really, really good learning tool. And again, using the Pico app alongside it, you can actually practice with the software, using the app for guidance before you even purchase a scope. So this is our new Picoscope 7 software. So for those of you who aren't familiar, this is a much cleaner looking menu structure. So when you first download it, we've got a minimal amount of menus that are shown. And I'm going to do this live in a moment, so don't worry too much. But what you've got down here is a load of options that you can click in and out. So as you become a more advanced user, you can bring more advanced features onto the menu. Basically customize the way the menu works for the way you want to operate and the testing that you want to do. So it really is much easier to use, certainly much simpler to navigate around, just to make the user experience. And also what we've tried to do with Picoscope 7 is to give you larger buttons. So as a lot of people kind of move to more tablet diagnostic systems, you've got those big buttons. You can actually work it quite nicely with finger control on a tablet. So we do that here sometimes as well. Okay, so rather than me kind of blither on about it, I'm actually now going to flip to another screen, and I'm going to open Picoscope 7, and I'll show you where you go and download it, and also I'll take you through the main menus that you're going to need to start to learn working with Picoscope 7. Okay, flip to the other screen if we can, Ben.
Okay, just before we take you through the main features and menus in Picoscope 7, I'm just going to take you onto our website to show you where you can download our software. So just to recap, it's www.picoauto.com, and you come to our homepage, and then it is under downloads that you need to be. Just to mention once again, our software is free with no monthly or yearly subscriptions or fees. So probably by the time you get to this stage, it should be on Automotive 7 stable, but for now we are just downloading the beta version. Principles is exactly the same, so we click our download button, and then as you will see, we are now downloading our software online. And as is usual with downloading online software, you just follow the instructions to install the software, and then shortly you will see on your desktop both an icon for Picoscope 7 Automotive and also Pico Diagnostics. So once you've got them, we're going to start work looking at Picoscope 7. Okay, now we've downloaded our software, we're going to go into our Picoscope 7 Automotive. Just a note to begin with, I have not got Picoscope connected, so we're going to run this in demo mode. So even before you buy Picoscope, you can run it in demo mode and do everything that I'm about to show you now. So first of all, we're asking to connect a device. As I said, we're going to run in demo mode, so we just choose that icon and click OK. That will give us a demo signal on screen to manipulate and start to work with. Okay, so as you will obviously see straight away, front and center now are our guided tests. So these are really the very basis for, certainly if you're new to working with Picoscope, this should be your first port of call. So we've got in there all of our charging and starting tests, our sensors, actuators, ignition systems, right the way through to now, of course, working on electric vehicles. So we'll have a quick look at a sensor test. So let's have a look at crankshaft position sensor. So you've got all your different types of sensors for the crankshaft. You may not know what one is on your vehicle. Now, of course, you can use technical data to find that, but if not, then just choose one, and once you start capturing data, you'll understand which it is. So we'll just use floating with a running, and we're going to pick guide and settings file. That's important. If we pick settings only, it will just set the scope up to run that test, but in this case what we're going to do is have a look also at our guided test here, which shows you what to do. So as with all guided tests, we've got how you perform the test, so how you connect the scope to the sensor. Let me give you an example waveform, some waveform notes, so why the waveform is the shape that it is. Then also a link to our waveform library, and we're going to come back to waveform library in a little while, and then some further guidance, so how that sensor operates, what to look out for when things go wrong. So just some useful help and advice. And like I said, we've got over 150 guided tests, and this sort of information is available for all. So let's just minimize that. What we'll also notice in this case is that the scope has now set itself up. So our voltage scale is set, plus or minus 20 volts. So this is a two channel test, so both channels are set plus or minus 20 volts. So look, we got that plus or minus 20 volts this side, plus or minus 20 volts that side. And just now to look at some of the other features. First one I should say, down here, you can fully customize the way that Picoscope 7 looks. So if you want your settings to be on your main menu, if you want instruments, if you want full screen mode, as you'll see, they just add into there. Okay, so let's come back. So let's just have a very quick look now at how we would set our voltage and time base. Of course, this is a preset coming off our guided test, but equally we could change that. So we can change the probe that we're using. So in this case, it's a ×1 probe, so a standard test lead that it's set up for. But you know, we can change within the software if we want to, and we can change our voltage scale. So I change that plus minus 50. You'll see that that will change, and I can scroll that down so we get enough room on screen to get those plus or minus. And then when we have finished on the menu, we click on there. Then we have our time base. So that is the settings along the base of the screen. So we are 20 millisecond divisions. So that's 20, 40, 60, up to 200 milliseconds. So that's the time across the screen. And we can change that if we wish. And then we've got things like triggers, waveform buffers, which we'll get into. And then, of course, as you've seen through our presentation today, we'll get into kind of opening, saving files, so on and so forth. So that's a really quick look at the software. In the next section, I'm going to have a look. I'm actually going to connect the scope, and we're going to look at our waveform library and starting to work with Picoscope. Let's have a look at one of our more advanced features, but certainly one of our most useful is our new waveform library. And what you'll notice to get on our waveform library is we need to have Picoscope connected. So at the moment, as you know, I haven't got Pico connected, and it will actually not allow me to get in. We can see it in the background, but we can't. So what I have to do is connect Picoscope via a USB, and then connect device. Here it is. So click OK, Now we have Picoscope connected. So now we would now be able to log in to our waveform library. So for those of you who haven't seen the Picoscope waveform library before, we have to have a login, username and password. That is the same as we use for our forum. So back to our website, www.picoauto.com, sign up to our forum, create your own username and password, and it is the same to here. Once you have done that, you then have access to over 6,500 waveforms that we can search by vehicle make, by vehicle model, and all the way through to engine code. We can look at fuel, so we can look, and we're even looking at specific sensors. So I'm just going to filter down our 6,500. So we've now got 6 waveforms. And of course, if you were looking for, say, cam and crank measurement, you could search specifically for that. There's obviously a lot on here. I'm going to take this one. There we go. We can open. And what we will see in the background is it's opened that file for us. So now we've got a huge amount of information, but again, it's allowing you to view and understand what a good known waveform is. So we've got, hopefully in here, yeah, so someone's been really helpful and they've told us what we've got. So channel A, so our blue channel, is a crankshaft sensor. Channel B, camshaft sensor, injector current, so on and so forth. If I start the scope, it is now just a good opportunity to show you probe mismatch. We'll cover probe mismatch as we go through the day, but this means it actually shows us what we would need to connect to run this exact test on the vehicle you're working on. So in a scenario where you've got an Alfa Romeo there that you need to look at and you're looking for a cam and crank measurement, all you'd have to do is plug in to channel A. So look, I've got my red channel B, so it's telling me that we've got a good match. But what happens when I plug in the wrong probe? Actually, I've put a 2000 amp clamp deliberately, so it's telling you that it's incompatible. If you choose to run the test with the current probes, of course you still can, but this is really there to help guide you set up to run a known test on vehicle and collect the right tests. So actually that's a really nice, very quick overview of waveform library, probe mismatch, and starting to work with Picoscope 7. Anyway, we're going to go back and run through all this on our live demos today, but hopefully that gives you a good start.
Okay, I know that's a lot to take in, but as I don't think I mentioned it earlier, but we do of course leave this video up, so you're welcome to come back and look at it again on catch up. You can download the software and kind of follow along what I've done there. So hopefully that was useful. There was a question on chat about whether Picoscope 7 worked with the older models Picoscope. Yes, absolutely. So it works with the 2 previous models of Picoscope. So it covers everything kind of ahead of the last one. That it won't now work with is the ADC12, which is 15 plus years old, I think. So certainly if you've brought a scope in the last 15 years, it will work with the Picoscope 7. But of course, where you really get the huge benefit is now with the BNC Plus connections, which we're going to move on to. Just one last thing about software evolution. As you may or may not know, we do make kits for more vehicle manufacturers globally than any other oscilloscope maker. So you'll see in that picture there along the left-hand side, some of the vehicle manufacturers we work with. The scope and the software is exactly the same, just to be very clear, but it is that work that we do, particularly now as we move into future technology, that drives the product and the software forward. That picture there of the Volvo software just gives you an indication of the only thing that we do change within the software. So where we have our guided tests in standard Picoscope, some of the vehicle manufacturers choose to put in, rather than having their own guided tests, they'll actually put in waveforms from their own vehicles into that menu. So it just allows their technicians to go in and they'll search by vehicle make, by model, by engine code in there, and they'll get obviously a waveform from the vehicles they're working on. But as I've just shown you back there, waveform library, of course, gives that to the aftermarket, effectively the same thing, and obviously a much wider range of waveforms. So yeah, just be aware of that. We do a lot of work with vehicle manufacturers. The beauty of that for the aftermarket is it really drives the product forward. It's why we've ended up with BNC Plus, and also Picoscope 7 has been driven that way by the demands of the vehicle manufacturers. Okay, so enough on software, I think. We're going to have a look very quickly at BNC Plus, and this is very much designed around making the user experience easier, making it faster to capture data, and just the whole setup process is much, much better. Great for a new user, but actually also for an advanced user, the fact that you connect, you connect an adapter, you connect the current clamp or something to the front of the scope, and the software automatically knows. So for those of you with a BNC Plus scope, as you'll know, and it's no huge hardship, you'd have to connect a test lead, and then you'd have to tell the software what you connected, whereas actually with Picoscope 7 and the BNC Plus, you don't have to. It knows what you've connected. So it's much, much quicker. So yeah, we call that plug and play. The other real advantage as well is that for the current clamps, you don't need batteries anymore, because we can power through those extra connections. We can power the component or the test lead, or in the case of the current clamp. And that's certainly something, as we move forward with new probes, it's something that we'll be developing. So there'll be more powered probes coming to Picoscope in the future. Yeah, and I showed you a little bit when I was going through the software about probe mismatch. Really does mean if you connect the wrong lead to the wrong channel, it does get you back on track and tells you where you are. So we have a whole range of accessories that we can connect in. So test lead being the kind of standard, so what we call the ×1 lead, the standard test lead. And then on the end there, we have our 4mm adapters, and we can put anything from backpinning probes, which is what we saw in that earlier animation, right the way through various ways of connecting to a component. That's one of our breakout leads. We do a pack of 12 breakout leads, and Phil's going to show you through the whole kit in a moment anyway, so I'll let him run you through that. Then we've got our current clamps, like I said, no longer needing batteries. Coil unplug probe, so developed that for looking at coil pack signals, ignition signals, but that will work with any actuator actually, so don't be just using it on coil packs. If you've got one of those in your kit, you can capture data from any actuator, so experiment with it and use it. Then we have our ×10 lead, so this this replaces the attenuator in the older kits, because obviously we've got the BNC Plus connection, so we have to have a built-in lead, and then round to pressure transducer and NVH kits. So lots of ways to capture data, to capture our waveforms with the scope. So rather than me carry on, what I'm going to do now, I'm going to pass you over to Phil. Phil's going to take you through all of the components that are contained within the advanced kit, so you get to have a good look through each of those. Over to you, Phil.
So we're going to look at the scope first of all. This is the new 4425A. So we have really new different connectors on the front end. So we've got BNC Plus, so we've got our BNC connections there, but we've also got our little connectors there. So we now have each of our channels are BNC Plus, and this makes for really great features with the software now, that we can actually use it with resistance and temperature. So great little boot that comes with it. So we have a boot to protect it, and we can hang it from here. And then of course we have here the USB 2 or USB 3. So that's actually the great feature of the new scope. So we're now going to talk about the current clamps, because one of the major things that we now have, this is the BNC Plus. So here we have our connectors. So we now do not need to power up any of the current clamps with a battery. By plugging this into the scope, this will power the unit up. Nice big jaw, and as you can see, the clamp is a little bit thinner than it was before. So sorry about the mess of all the leads. So we then have here the 2060 current clamp. Again, this is BNC Plus, so great for getting onto fuse extensions, injectors, current draw and all sorts of things. So again, nice directional arrow, nice big jaw to be able to get our leads in there. So this is the new addition to the kit, again not requiring any batteries. So we also still have our back pinning probes, which are very, very useful. So we can use those, and the replacement needles are in there. We have a selection of clips within our box. So we've got our 4mm adapters, which are very good. We've got crocodile clips, small clips, and back pinning probes that actually turn around the corner, which are very, very good. And we've got the new battery clip here, which is very, very good for clipping onto batteries and earth points. So these are come in both red and black for all of our needs. S-hooks, of course, we've got the 2 S-hooks which come with the kit. Very, very good for hanging the scope into the engine bay, but also actually being able to stop leads going into the engine as well. What we're now going to do, we've got the safety guide here, which is always included with all the kits, explaining all the information you may want to look at in multiple languages. So let's undo the case. So let's talk about connection to the scope. It comes with 2 cables. We've got the USB 3 and the USB 2. So very, very good. Recommend these cables to everybody, because the Pico cables actually have better earthing and power supply than standard leads. So just remember that. So within our box we have a selection of 4 coloured test leads which go onto the scope. So we've actually got blue, red, green and yellow, and these have the nice new BNC Plus connectors. And then of course here we have our earthing point, and we have our connection to the component we're going to test. Just remember to pull the little tab out. So these come in 2 different lengths, so you can get them in 5 metre lengths as well. So remember, you've got 4 of those. So we've now got probably one of the most useful components that we use an awful lot now, which is the coil on plug. Because not only can we use this with coil on plug, but we can also actually use this on actuator parts as well. So again, this is BNC Plus, and we have the earth strap on here as we did with the original one that we had. So just to get it out of the way, we have a massive, great big roll of breakout leads, and these are available and they come in this great little pack, and they've got various sizes that you can look at and see. Really good attributes. We've got square ends, round ends and back pinning as well, so really nice application to the kit. So what we're going to do is just talk about this. Within the kit we have 2 of these probes. These are actually test probes for doing prime ignition and flex ray. So this replaces what was your old attenuator. So this is now a standard part of the kit. You have 2 of these in the kit. So all you have is a little bag of goodies that you can connect onto there to earth the unit out. But again, very good for flex ray and for looking at primary ignition. So let's just take some of these leads out of the way. So we now have our 4 standard secondary ignition pickup leads that we have. So we've got 4 of them within the kit. Again, B&C Plus, and we've got the earth strap as we've always had. So I've got 4 of those. Well, we're talking about ignition, we might as well all talk about the extension leads that we also have. So these are the extension leads with the earth strap, so that if you've got multiple coil pack, you can pull the coil pack out. Or if you want to do an extended road test on a normal single coil pack, you can pull it out and put this on top. So apart from the nice little kit of breakout leads that we've showed you, we have 2 test leads here. So we have what is the 2-pin AMP breakout lead. So again, you can connect this in, you can put your voltage up there, and you can put your current clamp round here. Really good aspect. And then we have another one, which is the 2-pin Bosch connector. Again, a really nice addition to the kit. So you've got your voltage supply there, and again, current on there. So really quick and easy way of getting to things. So we now have, within our kit, we have a selection of fuse extensions. And the nice thing about the new fuse extensions is they have a little pickup for earth. We have, of course, we put the fuse in there to protect the circuit, connect that in and put our current clamp around there. So we have 4 different sizes of these, all within the kit that you can use for diagnostics. Think if you can get to something in the fuse box and it is really easy, you can then actually look and see and connect into it. So, one of the new features, we now have a temperature probe. So one of the new features that we've actually got within the kit now with the 4425A is that we can do temperature. So this is your temperature probe. The other feature that I did talk about when we first talked about the scope was actually resistance. So this is our resistance test lead. So we can actually look at this and see what we've got and do resistance reading. And last but not least, we have our parking sensor. So we have our little parking sensor that we've always included. This is B&C still, so we can connect to the vehicle. So all the things within the kit are listed. We have a huge amount of items here. Contact your local Pico distributor or contact Pico, as you can buy all of these items singly if you need to. But I hope you've enjoyed looking at the contents of the kit, and we'll now try and put all these things back in again. But any questions, come back to Pico or go to your local distributor. Thanks.
Thanks, Phil. That's great. Yeah, so that takes you through, hopefully, most of the components in one of our bigger kits. So, good. Well, we're going to get on to some testing now. Just one final note on choosing the right kit. Just to reiterate, worth downloading the app. And in there, we take you through how you choose exactly the right kit for you. So you've got all the kit content there. And then we show you what's in the kit. The beauty of the app is you can click into information about each of the accessories included within the kit, and you can look in there and see exactly what they are. So for new users, it does just help you understand what's in the kit that you're looking to purchase and exactly what testing you're going to be able to do with it. And loads more in the app as well, so all the accessories, pressure kits, MVH, EV, so on and so forth is all there. So hopefully you've all downloaded it now. You can have a good look around. Okay. We do like to go for all the basic stuff first because we can't assume everybody knows everything. So, but now we are going to get on to doing some testing and allow Phil to show us some connections live on vehicles. So in terms of working on vehicles, everything that we do today, we're going to look at 3 basic principles. So we are going to show you how we make that connection. We're going to bring out bonnet cam and we hopefully be able to show you the connection that Phil's made and is making. Then we run. So how do we run the test? So how does the vehicle need to be performing to capture that test? Is it just on idle? Sometimes we only need the ignition on. Sometimes we need to go and do a road test. So we'll explain to you what standard vehicle conditions are to capture that test. And arguably the most important thing, reading their waveform. So once we've captured our data in the correct way, how do we read and start to understand how a waveform, is a waveform good, bad, and how do we go and find more information about that? One final thing with Picoscope, we're not powering any components in terms of we're not putting any voltage into the system, so you can't fry an ECU by using Picoscope. It's perfectly safe to use. All we would always say, if you're unsure, go through the guided tests, and use that advice to make sure you do connect in the correct way. Okay, so we're going to have a look at multimeter versus Picoscope, and the idea behind this really is, even if you don't have an oscilloscope, I'm sure you're using a multimeter every day. And we'd argue, making a connection with Picoscope is no more complicated, but what you see in terms of the detail is much, much more valuable to you as a technician. So we're going to connect to camshaft sensor, and Phil's going to show you this live on the little TT in a moment. So we're going to use a backpinning probe. I think we're going to use a backpinning probe or a breakout lead. So we'll make our connection. And to capture this, we need the engine and the vehicle on idle to capture this test. And what we're going to see with the multimeter is something like this. So we've got 12.16 volts on the multimeter. What does that tell us? Well, it tells us that that component is operating, but it doesn't really tell us anything more than that. So then, same connection, and what Phil does is piggyback the two together so we can see the two displays on the screen together. And again on idle. So we are going to capture something that looks like this. And if I zoom in, it'll be much clearer when Phil shows us. Actually, what we see here, this is a nice square-edged waveform, what we'd expect to see, fairly typical camshaft sensor. It's not very clear, but we've got a 15-volt sensor actually to 0, so it's quite unusual, this one in this example. Most of them are 5 or 12 volts, but you do get the odd 15 one. Why is the multimeter showing us 12 volts? Well, actually, all that the multimeter can do is average. So it's averaging, what we're seeing here. So it's going 15 down to 0, back up to 15. So if we took an average of that, which we can do with a measurement, but we won't overcomplicate things now. So what the multimeter does is gives us an average of what it sees. Okay, I think we'll go over now to Phil. He'll talk you through the test and I'll man bonnet cam and we'll show you this live on the little TT. You ready, Phil?
Yeah, we're ready. Hi guys. Right, what we're going to do is just talk about connections. So, what we've got is our BNC Plus lead connected in to our scope, and all that we've done is we have actually connected into a breakout box, because the test lead that or the sensor we're testing is right down there. So we've put in a breakout lead that comes all the way along. So we've got a little 4mm adapter in here, and we've connected up onto there to our test lead. Our multimeter is in the other end of it, and of course what we're doing is we're then going onto the battery for the negative for the earth, for both the voltmeter and the scope. So as you can see there, we haven't started it up. So what we're now going to do is just go to the software. So for anyone that's never ever used a scope before, we're going to go up to our sensors, and as John mentioned earlier, remember that we're not actually putting anything in, we're just going to read what we see on the screen. So we have a choice of 3 sensors here, and most people say, how do you know? Well, inductive or Hall effect are the main ones that you're going to see. GM did some very unusual sensors that were AC excited. Don't see many of those nowadays. So what we're now going to do is look at the Hall effect, and we're going to load the software onto my screen and just see what it shows you. So here we've got an overview of our test, exactly the same as we've done on our vehicle. We've used a breakout lead, and then what we're going to do is pull down to tell you how to connect, and an example waveform of what it should look like. Now remember, every vehicle is going to be slightly different to this. So this is where we look at the notes, we then look at the waveform library, and we also have information about the test. So we've looked at all of that, and we've even got relevant fault codes at the bottom of the page explaining what they are and what they do. So we're going to bring the software back up. We're going to close this down, and effectively what we've got here is our voltage on our time, as John explained earlier. And there are occasions when we may need to change the voltage scale. So what I'm going to do now is I'm going to start the car up. We're going to start the vehicle up. We're going to look at the voltmeter, and then we're going to go back to the software, and we're going to see what we get. So let me push the start button on the software. Okay, so instantly when you see on the screen, you will see that we've actually gone over voltage. So what we need to do here is just bring down. Okay, so we've gone to 20 volts, as John explained earlier. And you will see that there is a degree of interference on there. So what I'm going to do now is I'm going to stop the software, and I'm going to bring down our measuring ruler, and you will see that it says 12.96 volts, and on the voltmeter you will see that we've got 6.5 volts on the screen. So exactly as John mentioned, 6.5 volts on the multimeter and 12 volts on the screen. So if we turn the engine off now, we've got our square waveform on the screen that you can see, and this is going to change quite dramatically depending upon what it looks like. And one of the questions that we tend to get quite often is interference. You will see here on the screen here that I have some interference, and this was what was actually making, when we started the vehicle up, that it was going over voltage. It was this little spike here. So one of the questions is always, why are we getting interference? Well, As you can see from the engine bay, we've got a lot of wiring that is open to the elements, so we can pick up information from anything there, or we can pick up the things from the lights above us. On this occasion, we're actually picking up a signal from our coil pack. So later on, we'll probably put the cam and the ignition together, and you can see where actually you can see the interference occurring. So don't disregard what you see on the screen, because that could be live information. We have a facility for filtering things out, but we always want to see the raw data, because there may be some important things in that instrument that we're seeing in that sensor that may help us to do our diagnostics. So again, remembering, if we look back at the screen, I can now go to vehicle details, and I can put in all the vehicle details of the vehicle that I've worked on. So we've got the chassis number, the make, the model, what sort of system it is, and we can then save that. And at the bottom here, we've got our camshaft sensor, and we can even type in here terminal 2 black wire. And when we save our waveform to our desktop or to the waveform library, all of that relevant information is saved with the test. So for a couple of minutes work, you've captured a waveform on a good car. You can compare it, you can share it, and you can put it on the waveform library. And it's really understanding how the waveform works. And again, most people go, well, how do you know which wire to go to? We could actually pin into these connectors here and look to see exactly what we've got in that. You would see the different signals that we get from going onto the 3 different wires. And it's really, we're never going to damage anything when we're looking to a basic sensor. We're just going to back pin or use a breakout lead and go in and test. Always remember to check that you've got a very good earth on either the battery or a very good earth in position, because that will also affect the signal that you see on the screen. So, you know, save your waveform, look at the data, make sure you've earthed out properly, and you should get a good pattern. And please use the waveform library. Thanks, guys. We'll go back to you now.
Thanks, Phil. Excellent. Good. So, yeah, just a very simple test, camshaft sensor. So our next test that we're going to look at is relative compression. Really, really useful kind of first stage test. Yeah, non-intrusive, particularly if you think you've got an engine issue. Really, really simple test to do. Again, single channel. So we've just got our 2000 amp current clamp, and this test, along with our other top 10 tests, are in the app. So effectively we've got top 10 tests in there that we have animations for, and also description. So the idea being behind it, if you're new to Pico, you can work your way through those tests, work on a vehicle, you know, preferably a vehicle that you don't have a problem with, just so you start to get used to capturing signals, seeing good waveforms, and you'll start to understand the shape of waveforms and what they should or shouldn't look like. So we're using the app as a tool for training and education as you start to use the scope. So in terms of how we make the connection, we are going to disable the vehicle fuel injection. So we are cranking in this case, so we want to crank the vehicle. We don't want to start the vehicle. We are going to connect, like I said, high amp clamp, so the 2000 amp clamp on channel A, so it's a single channel connection. And we're going to connect that battery around the positive lead, away from the battery. And we're going to start the scope. Obviously, we're going to press start on the scope, so we're capturing data. And then we're going to crank the engine. And in it for about 5 seconds. You'll see when Phil does it in a moment. We want to just see those nice, crisp and even peaks on the waveform, and then we can start to use the buffer, zoom and measuring tools to have a look in and examine the waveform. So that's what we expect to see. So if we've got a good compression, we should see those nice clip, crisp, clear, what we call sawtooth. So it's just like the tooth on a handsaw. So we want to see nice. If you've got a problem with compression on one cylinder, doesn't matter whether it's 4, 6, 8 cylinders, you will see it on here. And then we start to work on where the issue is. So yeah, just some notes there around what we expect to see in terms of we are going to see, you know, a big draw of amperage when we start to crank here, but then it will settle after a few revolutions, and what we want to see is those nice, crisp and even sawtooth patterns. We'll just have a look. Hopefully this will play full screen. This played a bit weird, the one I did, but hopefully we'll see it. So this is just one of our animations. One of the top 10. We do a lot of animations now. It's a great way we can show you, you know, how the engine, how the vehicle's operating against what the waveform looks like on that component. So there we've got our 2000 amp current clamp. So in this case, so we are taking the fuse out for the fuel pump so it won't start. So we get a nice cranking waveform. Crank the vehicle, and this is just showing you an example. Look, we've got a missing, if you like, a missing sawtooth. So how do we then start to work out, well, which cylinder have I got a problem in? Well, we need an ignition event. So we're going to use our coil unplug probe here on perhaps cylinder 1, and then if you saw, we got the ignition signal, and then you can count. Knowing the firing order of the engine, you can work out which is the issue with the cylinder. And then you can actually go on to the next test, the next obvious test, which would be using the pressure transducer in cylinder. And that would allow you to actually understand what's causing the compression set issue in the cylinder. Right. Before I crack on, we're going to go live back to Phil, and he's going to show you relative compression over on our little TT.
Hi guys, so first thing that we've got to do is get our 2000 amps clamp, and we're going to plug it onto our scope as we normally do. And you'll see from John's camera that we put the current clamp around our test lead. And of course, remembering that actually now we've got the new BNC Plus current clamps, we don't need to power them up with batteries, which is a great thing to do. So now we're going to go, and we're going to go on the software, and we're going to pick our test. So, as you can see on my screen, for any of you that want to set the screen up manually, of course you can do this, or you can just follow our guided test. So we're going to load the software just as John showed you earlier, and we've got our connection, we've got how to do the tests, and exactly what we've got on the screen. Now, we're going to have a little bit of fuel left in the system, because I've pulled the fuse out, but we've not been able to manage the software yet. So what I'm actually going to do is I'm going to close the software. I'll let John just crank it over for a minute. That's all right, mate. That's good. That's good. Right, okay. So now what I'm going to do is I'm going to hit the start button. Okay, John, you want to crank it over? Hang on, mate. We've got a bit of an issue. We're not. Yeah, the current clamp is closed. The jaws are making. Yeah, let's hang on, mate. Let's just check our connections. Yeah, we're Okay, John, try it again. Okay, we seem to have lost connection because we've got nothing happening there at all.
We've got a second scope screen open by mistake, have we?
No, we should only just have one. Okay, error calibration. Okay, what we got here? Disconnected, okay. Right, let's just shut the software for a minute. And then just open the software again. Just in case we've got an issue. Loading. Okay, so we'll go back to our test. Sorry about this, gents, but things always... Right, so relative compression, load the files. Okay, right, let's start the scope. Go on, John, try it again. Oh, let's check. I don't know, mate. Let's get another current clamp and try. Yep. Yep. Let's get another current clamp and just check.
Oh dear, never work with animals, children or oscilloscopes. We do that all the time, I can't tell you. I did notice that someone put in the chat that how awesome our current clamps were, so that may well have been the kiss of death on there. We'll come back, we'll let Phil try and figure out what the problem is, whether we have got a problem with the current clamp or perhaps something weird. We're going to move on to a wheel speed sensor test, and I'll explain it. So if we can just go back to the presentation, Ben. Phil in a moment. So again, another one of our top 10 tests. We're going to have Phil in the background, bless him. We'll do that. Why don't we do that after the break, Phil? We'll figure it out because we'll have a break because we've got one more, and then we'll go into a break, and everything will be fine, I'm sure. Because we're doing a relative compression case study, first one after the break, which is quite an interesting one actually. So let's continue with wheel speed test. So it's another one of our top 10 tests that you'll find, and you will get lots of issues with these systems. So in terms of how we connect, again, it's a single channel. You can connect to all 4 sensors at the same time. If you look at the guided test, it gives you the option whether you want to do 1, 2, or all 4 at the same time. So we've got to have the engine on, but ignition on, but we don't need to start the engine. And we need to start the scope. So actually what we do in terms of capturing data on a wheel speed sensor, yes, you can do it on a road test, but actually if you can just jack the vehicle up, which is how Phil's going to show you, we did a video earlier on that where we jack the vehicle up, and actually you can just spin the wheel and you can see then the sensor operating correctly. So we're just rotating it by hand to capture the data. And then once we've got our waveform, we can use obviously the usual things to measure it. So we are going to see a waveform that looks something like this. Clearly 2 signals there, so we've got 2 sensors at the same time. So we should see these nice clear, it's another square-edged waveform, will look something like that. They're not all the same. Different vehicle manufacturers have different sensors, of course. That's why the waveform library is so valuable. So if you can find a good known waveform from the vehicle that you're working on, then you know what you're looking for. And of course, technical data can help you out there as well. So that's what we expect to see. So somewhere in this case we've got is switching from half a volt up to 1 volt, and that's a good one. So again, come back to our little animation, and the animation is designed, you know, to help new users understand how you make that connection and kind of see how this operates. So in this case, we're going to do it because we can. The power of animations mean we can do it on a road test. So this is us capturing. So backpinning probe into a sensor is probably the quickest and easiest way to get in, and we've got that nice clear square edge, slightly different to the one we showed you. And again, what we're doing here, we can switch between the different sensors. If we suspect we've got a problem with one sensor, we can compare it very quickly on the screen between the good, what we suspect is a good one, and a faulty sensor. So that's a way to do that. So this is the video we did earlier with Phil, and he shows you just how we jack the vehicle up and then capture our wheel speed sensor. Run VT, Ben.
Hi, my name's Phil Rutt. I'm one of the automotive support engineers, and today we're going to talk about doing ABS sensors. We've got a little car here with an ABS sensor, so we're going to go in and talk what we're going to do. So what we've actually done is we've gone to the sensor and we've actually put a breakout lead, which is underneath there, which my glamorous assistant is going to show you. So effectively all it's done is extended the lead so we can put our test lead into the back of the breakout lead. We have actually earthed the connection to the battery because we have a rusty car underneath, so we want to get a good earthing point. So let's just take you to the software and show you what we've got. So we're going to go to sensors, and now it's just called wheel speed sensor. So we're going to go to that, and we have a choice here of 3 types: Hall effect, inductive, or magneto. So we're actually going to go to the magneto one, and we're going to load the files and just look and let you see. So how are you ever going to know which one? Well, normally if you go onto your technical data and have a quick look, it may give you a suggestion what type of sensor you've got, whether it falls into any of those, or just plug into the sensor as we're going to do now and see what we get. So what we've got is our test lead, channel A, connected to our sensor and earth. So we're going to use one test lead, and then we've got the information on the help page, and we're going to look at all of those things. Look at notes, waveform library, guidance, explain how the sensor works. So we're now going to shut the software down. Okay, so what we're now going to do is start the vehicle up, and then we're going to spin the wheel and look at the screen. So I'm just going to start the vehicle up. I'm going to push the button on the software, start it. Okay, and you can see we've got the screen, and we're going to rotate the wheel. Now, on certain bits of software, they may ask you to do it at a particular road speed, signal sense, speed. Some manufacturers, if you go over 20 mile an hour, may not record things. So let's just turn the engine off. And let's just go back a couple of frames, just so you can see what we've got. So really, all we're going to do is look at our signal, see that we've got a repetitive signal on the screen, and they're all about the same, and they are. And as you can see from here, yes, we have got a lot of interference, and we are going to get interference on these items, but we're looking for a repetitive signal that they're both working exactly the same, and they've got it on the screen. If we then had another breakout lead, we'd plug into the other side and we'd rotate both wheels at the same time to see what there is. So remember again, we've got our pages of data, so we can then look at, and that's as it's just going very slowly. So you may need to just look at your technical data to see if there are any limits on the speed of the rear wheel to capture the information. And then as we've got here, we've got this information, just look at it, and we're looking again just at repetitive signals, seeing what is happening, what we're going to see on the screen. Remember, earthing is a very important factor. This is why we've taken the earth to the battery, and a good connection. We've got a breakout lead on it because, you know, it's not very easy to backpin. You've got to then find a good connection in the car. And remember, earthing is so important. So again, we've got a signal, and I hope that you've enjoyed this little video.
Okay, great. So that's wheel speed sensor. And we're going to come back to our relative compression after break, although we've got to set up for another more complicated. So when we come back after break, we are starting to look at systems testing. So we're looking at multiple sensors together and starting to build up a pattern of how systems are working on the vehicle. So sorry, I know there's a lot of people put stuff in the chat. We'll have a good look through them through break time. Let's have a quick look. Yeah, so we're on UK time this end. Someone said my laptop time was wrong, or Phil. So yeah, no, that we are okay for time this end. So it is 12 minutes past. We will come back at 25 minutes past the hour, so 13 minutes. Let's not hope that's unlucky for some. And then we're going to get on to looking at some more complicated systems. I know also there was a question. Sorry, I'm losing my track a little bit. No, we are doing EV afterwards. What was it? Oh, I've lost my brain. About the laptop shutting down, and then it obviously closing the scope. I'm not entirely sure I completely understand the question. Can you send an email through to your local distributor, please, and then they'll make sure that I get it and we'll answer that properly, because I'm not sure I entirely understand what we should or shouldn't be doing. Just a general note, a point actually, if you've got something that you feel doesn't work correctly on the software, Pico 7, you have got, you can put feedback directly in the software. Now that feedback goes directly through to the software team. So anything you find on the software, be it a glitch that you don't think works correctly or something that you'd like improving, do put them through that way, because that does get directly through to the software team, and they do pick up on those. They have a monthly meeting where they look at any customer feedback. And some of the changes are implemented from customer thoughts and ideas through that feedback source. So do that as well. But yeah, just drop me a note via the distributor, and I'll try and make sure we give you a proper answer on that one. Right, gone on again. Yeah, so we'll see you at 25 past the hour, so a little over 10 minutes. Welcome back, everyone. I've got serious jealousy of thought of someone with their pizza and their wine and hopefully a lovely summer's evening down there with you guys. So enjoy. Anyway, I've filled up my coffee cup and we're good to go in part 2. So we're going to start off looking at understanding waveforms, and this is really about where we go. And capturing waveform is one thing, but of course the most important thing is how we analyse and understand whether a waveform's good or bad, which is of course where most of the skill comes in. So again, we're back to our connect, run and read. So this is just an example of a fault. We're back to our wheel speed sensor, but as a technician, how do we know when we capture our data what's good and what's bad? So here's our technician. We've got our data from our road test, but until you start to understand what various waveforms should look like, where do we go and find more information? Well, first port of call should be waveform library. So of course that talks us through how we go and capture our data, but there's also a huge amount of information in those guided tests about that actual component, how it operates, what changes in the waveform when things go wrong. And then of course, as we keep, and we're going to keep banging on about the waveform library because it's so important. Searching by vehicle make, by model, by engine code, so for the vehicle you're working on can really be 3/4 of the battle if you can find a good waveform on there. We're over 6,500 waveforms, I think, on the waveform library now. So here our technicians downloaded a waveform. What else can he look at? Well, Pico, like serial diagnostic tools, they're not the only tool in the toolbox. Having access to really good technical data is really important. So in this case, we've got a service bulletin. So again, search through that, and we've found a known. So this is a known problem on these vehicles. And even there, look, happily, we've got our waveform. So it's showing you what to look out for, where things have gone wrong. So, look at the guided tests, try and get a good known waveform, but also use your technical data. Here we are. Replace that faulty component. What's the final thing we should do as picoscope technicians? We go and recapture the data once we've fixed the problem. So now we've got, there we are, that nice square edge waveform, no gapping in it, so we know that we've fixed the problem. So that's a really important point. Making sure that you verify you fix a fault by recapturing the data, recapturing the waveform. Good. Okay, so a little bit about the waveform library. And the beauty of the waveform library is effectively you've got 6,500 waveforms now. Effectively every one of those is like a guided test. So if you've got a fault with a vehicle, and you can search by vehicle make, by model, by engine code, and you just download it, you can use that to effectively connect to the vehicle you're working on in exactly the same way, capture the data, and then you can compare the good known waveform with the vehicle data that you're working on. So it's a really key point. Use the waveform library sometimes as your starting point, particularly as you start to build your understanding. Once you've started to run tests, cam and crank will become second nature. Relative compression will become second nature. We're going to come back to that in a bit, but we really want to kind of carry on with the waveform library. So, being able to get in there and get a good known waveform is going to get you starting on the right bit. So what Phil's going to do now, actually, he's going to do that. He's going to download a waveform from the waveform library, and then he's going to connect to our car, and he's going to show you cam and crank. Also how we look at cam and crank in terms of engine timing and an ignition event. Right, Phil, hopefully we're set up, and this one goes all to plan. So over to you, Phil.
Hi guys, right, just a couple of things to remember on using the waveform library. One is the picoscope's got to be connected to the laptop. You've got to have internet connection, and you've got to log in as a user for the forum group. You then put in your email address and make up your own password. You type it in, and then it allows you to look at any of the 6,500 odd waveforms that are there. So what we've got on the screen now is, you will see that I have actually gone on, picked down the particular vehicle I want, and I've downloaded the waveform, and it's here in front of us. So what I'm now going to do is, we've got cam, crank, and I've now put my ignition secondary coil and plug probe onto cylinder number 2. So what I'm now going to do is, I'm going to start the car up, and we'll see exactly what we get on the screen, and we can talk a little bit about what we've got. Right. So I'm about to hit the button on the screen, and everything will light up. So here we have, let me just stop the software for a minute, turn the engine off, and we'll talk through exactly what we've got. We touched on it a little bit earlier about interference. So here we have, we've got blue channel, our cam sensor, red channel, crankshaft sensor, which is inductive. So we talked about interference, and what I'm going to do now is, I'm just going to pull up our coil and plug probe, and you will see that that interference that we've got on our coil and plug probe, if I zoom in, is actually picked up on the screen here. So you'll see that our spike in our cam sensor, and I'm going to bring it down. Yeah, so can you see that that exactly marks the same? So we've now got rotation. So if we're going to check timing, we need to have a good cam and crank, and possibly know on either a number 1 injector or number 1 coil pack, so that we can actually start counting the teeth. So what we now can do is, we can count the teeth, we can use our rulers, and we can do lots of things with what we've got on the screen to see exactly what's happening. So again, this is the beauty of downloading stuff from the waveform library. We can look at the waveform, we can measure different points, we can use it as an example, as John has said. We can then also put other things on it. So like today, we put the coil and plug probe onto number 1, so we can now start to see what's happening. So, you know, you've got camshaft sensor, which is a Hall effect, crankshaft sensor, which is inductive, and we've got a coil on plug onto number 1. So we can start to build a picture up exactly of how strong and the information is about this engine, what's going on. We can compare it. There are some really good case studies on the Pico website. There is one on a particular little Volkswagen Polo and a Subaru with issues with timing. If you want to go and look at those, please, they have a really good read. But just backing up what John said earlier about using the waveform library, downloading the information and using it and looking at it to see how we can make a better diagnostics of the jobs that we're doing. So we're going to go back to Ben now.
Actually, could we just have bonnet cam for a moment?
Yeah.
Sorry, nobody wanted to see that at any time. I'm just going to show you, I don't know if you can pick that up on bonnet cam, but when you connect the leads in and out, they actually correspond with the colours of the test lead. So when it's a standard lead, you'll see they're solid blue and red, but actually with the coil and plug probe, you'll notice that the body of the coil and plug is green and red, and you'll notice that actually the lights there are green and red. I'm not sure how well that shows up. But the idea behind that is, we can go back to the main my camera now if you want. The idea behind that being that actually, as we get all of our guided tests sorted out, effectively you'll be able to, once you download the guided test, the front of the scope will light up and show you the correct colours for the probes you need to add on. So it's another way to just make it simpler and easier. Just a very quick note on the relative compression test. We think that the issue is probably caused because someone's updated the file on the guided test, and there must be a glitch on that which is stopping that working. So we'll have a look at that when we get offline. Phil's going to try and we'll just move on a little bit, and then hopefully towards the end Phil's going to get one of his own relative compression files out, and we'll run that test towards the end. Right, so that's waveform library. Just very quickly, just reiterate what Phil said. To use the waveform library, you do need a username and password, and you get that from signing up to our forum, which is a really useful and valuable source of information. Anyway, you've got to have Picoscope connected, so it's the only thing that we protect for our Picoscope users. And of course, you need an internet connection to gain access. And then, like I said, you know, it gives you access 6,500 plus waveforms. And, you know, download them. You can download them for a single component. So even if you've got 4 waveforms that are captured and you're only interested in, say, camshaft sensor, you just download the one you're interested in. Or, of course, you can download the whole system file. And then, you know, we can use reference waveforms to show things on the system. Yeah, so this is just showing you what a reference waveform does. So effectively, you can pick any live channel. You can create a reference waveform. You can change the color of that reference waveform so it's different from, you know, the standard red, green, blue, and yellow. So then, if you keep those on the screen when you capture your live data, you've actually got those held, those good known waveforms, so you can do a direct comparison on the component that you're working on. So that just takes you through very quickly how that comes together. So that's reference waveforms, which I know I showed you earlier. Right, we're going to have a look at some case studies now, actually, just to try and give you some context about where we use different tests. And we're back to our friend, the relative compression test. So verifying a fault. This is a case study from one of our technicians from our USA office. And we're putting together, he's putting together a full video on this because I think it's quite an interesting one. So just a reminder here, this is a good known waveform. Yeah, we would have showed you that had we had Phil had a little bit more time. So we're expecting to see, hopefully you can see that okay on your screen, you get these really nice clear sawtooth pattern. When our technician in the USA captured his data, so this is a 6-cylinder engine, which becomes important. So this is our captured waveform, and actually if we look at it, certainly without zooming, everything looks pretty good actually. And I know Randy, who captured the data, thought, well, I don't really see an issue with this engine, even though it wasn't running correctly. And he felt like there was an engine running issue, but he couldn't, from just the first glance at relative compression, he couldn't really understand what it was. So this is where that, I mean, talked at the beginning about 400 million samples a second, being able to have that much data means we can really, really zoom in and see the detail. Now, hopefully you can pick it up on the screen. So these, what we call, we always refer to them as sawteeth. When we were looking at it before we zoomed in, we couldn't really see anything. But look here, how there is one that's lower. Now, bear in mind, we've got 6 cylinders. Actually, at this point, it looks okay again. and then back along, back along. So there's definitely an issue here, but it's not happening in every complete revolution of the engine. So it's a really weird one. So yeah, just a point in there. But look, when we get over here, it happens again. So when technicians started to research how that engine actually operates, and certainly it's not something that we see in the UK really, but it's clearly something that with a US engine, he realised that actually there's something clever about the way the valve, so this valve actually rotates. So we've got obviously 6-cylinder engine, 6 compression towers. So we have something in here that we've got these partitions, so you can set these up. And this is a really easy way. So it's a different, they're partitions, part of the rulers, so we can actually see each of those spikes, and then you can move that across and see each. So actually what we've got is 6 cylinders, obviously rotating, and every time they rotate, actually the valve turns slightly as well, which is why, and that goes through 4 positions, that's why we only see that sawtooth in lower compression after every 4th complete 6 rivets, so 24 basically partitions. So we can use our partition rulers there to just help us align and try and figure out where the problem was. So again, Randy's probably one of our most experienced technicians. He understands how vehicles work, but he was completely, he just wasn't, he hadn't seen this before. So, technical data clearly was his friend here because it allowed him to understand how that vehicle, that Chrysler engine was working. So there you go. So I'll just put that in so you can see where we get to those points. So that is 6 cylinders and obviously the rotation of the valve. So then the next thing that he did once he'd verified that we'd got a fault in one of the cylinders is to use an ignition to understand which was the faulty, and then we've gone in cylinder with the WPS. So we've got our pressure transducer. I'm just trying to think. So this is our cylinder 1. So this is actually it suspects this is a good waveform. So this is in cylinder with the pressure transducer. And then we've got, I think this was cylinder 3. Look how this changes. Now this is really, really telling. So all we've done, remove the spark plug, put the pressure transducer in the same as we would a gauge. The gauge wouldn't show you this detail. Look how our compression towers are changing as that valve is rotating. So we're only seeing an issue every 4th junction. So clearly it's a problem with the way that valve's working. So yeah, down to poor valve sealing as it rotates. So really, really interesting one. Like I say, Randy's actually working on the video to do this now. That will go up on our YouTube channel along with lots of other case studies. We're trying to turn more and more of our case studies into videos. It's a really, really nice way to show you how we apply Pico to a problem, and it's a really nice way to do it. So yeah, and once that video goes, like I said, we're going to YouTube, we'll also put some of these case study videos into the app. So download the app, as I've said, and you'll get a little notification there when something new appears. Right, I'm conscious we're running over time actually, so my apologies. So yeah, if you're interested in WPS compression, which I argue you should be, there's a whole series of videos on our YouTube channel where Steve takes you through looking at that in cylinder, and again, some videos on the app also. Right, let's have a look at parasitic drain. And this, I don't know whether whoever asked me the question about laptop shutting down was trying to do battery drain, but this is obviously one that we want to capture over a long time scale. So it's common, you'll see it quite often, battery drain issues. So we've got a situation here where we've got a problem So basically the owners just got used to the fact that the battery constantly runs down. They've tried to replace battery, so on and so forth. And this is one of Steve's, actually, so it's one of Steve's. So what this is us capturing over a huge time base. And effectively, it takes, I think this was about 10 or 12 minutes to shut down, which is clearly a lot longer than it needs to be. So we can see the drain soaking up the battery. I'm just going to buzz through this because I've got actually the video which Steve has put together, which explains it certainly much better. So effectively, once we could see that the system's not shutting down correctly, then it's just a case of, with everything connected, we start to remove fuses to try and understand which part of the vehicle is causing the problem. It actually turned out to be the central console. An expensive, slightly older car, expensive to replace. So in the end, Steve fitted a relay to solve the problem. Right, where are we? We're nearly 2 hours in. I didn't realise it would take this long today. Apologies to everyone. I think we're gonna run Steve's video just talking about parasitic drain, and then we finish off with a nice session that Ben's put together with us on EV. I think we'll finish in about 40 minutes with a bit of luck, so apologies we're a little over the 2 hours, but hopefully these bits will be most interesting for you. So yeah, if we could run the video that Steve did earlier for us on parasitic drain, Ben, that would be great.
Hello, we're going to look at parasitic drain measurements now using the BNC Plus 60 amp clamp. So with this hybrid vehicle, we'll connect this clamp around the battery negative terminal, and that will capture current flowing to and from the battery. The orientation, the arrow will face the battery negative terminal. So we'll use guided tests because that will set up the scope for us, and we'll find these in Pico Scope 7 under charging circuits. So parasitic drain, battery, and its guide and settings file. So here then we have how to connect. There are alternative ways of connecting if the clamp jaw is not wide enough to go around one single cable. There's the jumper method there we described. There's our example waveform and further guidance and links to the website as well, which will take you through additional tips for measuring parasitic drain. So let's minimise. There's our reference waveform, and here we'll start the scope running because I just want to talk about connecting BNC Plus. So channel A is connected across battery positive and negative, and channel B is going to be a current clamp around the negative cable. Now just note, upon connection, BNC Plus, there's a spike there just upon connection. The scope has restarted, but you can see there our 0 point, and we are on 0. If I just pull this ruler down here, type in 0, yeah, we are on 0 point. So we'll place this lead now around the battery negative cable, so that's the arrow facing the negative pole. And we should actually measure now parasitic drain. We can see it there that we are now above the 0 line. Let's bring in an additional ruler. So our current parasitic drain level is 82 milliamp approximately. So if we now lock the vehicle, and we'll see there that we overrange. The reason for that is we're now powering door locks. The vehicle has folding mirrors, and we'll also go into a shutdown phase. So various networks will still be awake at this point in time. Given time, it'll take approximately 30 minutes, some vehicles 45 minutes. You just refer to manufacturer specifications for that. But over time now, we'll be able to capture the step down process as this vehicle finally goes to sleep. So the vehicle has finally gone to sleep, and it's taken over 30 minutes to do so. Let's have a look at the capture and look at the stages of shutdown. So stopping the capture, filtering is applied. So during capture, the waveform would have actually taken on this form. So take the filter off. Okay, but this is applied automatically when you use the guided test. And stopping the capture applies the filter. All right, so initial stages then. Here, let's zoom in on this area. We've got our initial parasitic drain before we actually lock the vehicle would have been 59 milliamp. And we lock the vehicle, we see this inrush here, there's a lot of activity. This will be from door locks, closing, folding mirrors, etc. And then there's a period of activity from various networks. So if we start from this point here, during the first step down for 25 seconds there, we have a parasitic drain of around 817 milliamp. So the next step down is about 10.9 seconds after, where we come then down to 695 milliamp. Third stage, approximately, let's just line through there, was 1 minute 58, and there we have 285 milliamp. All right, so we go from inrush, from locking, step 1, step 2, and step 3 on this particular vehicle. Now, vehicles will differ, of course. Finally, we come across for 15 minutes 35 seconds. Let's take away a few rulers. We have a parasitic drain of 85 milliamp. Okay, so we're looking for below 80 milliamp. So we can call it 90 there. But we do see a final step down here where we finally truly go to sleep. And at this point here, we are at 55 milliamp, which is kind of where we started originally. But if we go from start to finish, from this point here, right to the very end, well, sleep time, the vehicle fell asleep here after approximately 17 minutes, 22 seconds. Our entire capture time was 29 minutes. Yeah, please refer to manufacturer specifications, because this will change from vehicle to vehicle. It'll always change with temperature as well. There'll be vehicles where cooling fans will be running continually, post engine off, post ready off or shut down. That will of course increase parasitic drain time. What I'd like to do at this point is just show you how parasitic drain can be affected by purely activating a door lock switch, for example. So we are, parasitic drain is running here. We're still connected as we were before, so channel A is across the battery, channel B is measuring current, and we have, take away all these rulers, parasitic drain at this stage of approximately 453 milliamp. If we just press the tailgate button as though we were going to unlock this vehicle, yeah, we do see an increase in parasitic drain. And we've now come up slightly. We've now actually shut back down. So let me just pause this, zoom in on this area. And you can see that here, let's zoom in on that entire area. That's better. So here we had parasitic drain. We then operated the tail door button. So the door is locked. All we're doing is pressing a button as though to release the tailgate. And we saw an increase there of 421 milliamp. So just shows you, even though the vehicle is asleep, pressing smart entry buttons, tailgate release buttons, even though it won't gain entry, you can't gain entry to the vehicle, you'll still increase parasitic drain. I hope that helps.
Right, we're back and we've solved the riddle of the relative compression test. So we ran this test yesterday afternoon, no problems with Pico Academy, and yet weirdly today it doesn't work. There's clearly a glitch with the relative compression test in Pico Scope 7. So what we've done actually, or what Phil's done, I said we, that was a royal we, we've actually opened Pico Scope 6. So it's a good way to check to see if there's an issue. So we've got Pico Scope 6 with, if we get a Phil's screen, so he's downloaded the guided test on Pico Scope 6, and we've got the same connection, so 2000 amp current clamp. Someone asked, we always show it on the positive battery lead, you can do it on the negative, it shouldn't make any difference. And we've got our connection in here so we can see that we're connected because we've got the blue and the red. I'm going to nip round and crank for Phil if we're ready.
Right, we're going to push the button to start the software and you'll see it sitting there waiting. John's going to crank it over. That's it, lovely. So, as you can see on the screen there, that is perfect. So we apologise about our issue that we have on the software, but we will put a bug report in afterwards and see. We did actually try a different current clamp, and we even tried the current clamp on the injector, and they all worked, so we knew it wasn't the clamp, so we do apologise, but it is it's just one of those things that happen sometimes with software builds. Sorry about
Right, great. So, yeah, these things are sent to try us anyway. Right, we're going to buzz over to EVs. I know there's a few questions on here. What we'll do with the questions, if we haven't caught them up today, we always go through them afterwards, and we will send through answers to all the distributors, so any questions that we haven't picked up live, I will have a look actually once we get to the Ben's video on EV and try and answer them right at the end. Okay, so future technologies, different countries around the world are at different stages, that's for sure. We're seeing a huge ramp up on EVs in the UK as, of course, people become more aware of the environmental issues surrounding climate change. So we all know we've got to change, and it will drive this technology faster and faster. I'm absolutely convinced of it. So what we're going to just do here very quickly is just to look at the main components with the EV, because of course everything's changed, but to some degree everything's basically the same. So we've got our supply equipment, so that is our charging point either on the wall or clearly in a gas station, and we take our power from that through our power delivery module, and that's effectively what makes that power and pushes it into the battery for storage. So effectively our battery pack is just the same as a fuel tank to some degrees. They're no different. And there are issues around fuel tanks just like there are with batteries, but we can test and look at that with Picoscope. And then from that battery, we run it through our inverter and our controller into our electric motor, and of course that's how we drive the wheels, drive the train. We are starting to see increasingly gearboxes fitted from those electric motors. Of course some electric motors are by wheel, but I think we will see as the quest for more miles out of the same battery, I think gearboxes will become more important for electric vehicles. And then of course we're just driving the wheel, so we've still got all the drivetrain that we would have on a traditional ICE, so internal combustion engine vehicle. And of course all the other systems, all the 12-volt systems around the car still remain. So whilst everything has changed, so much is the same. And as we said earlier, we do a huge amount of work with vehicle manufacturers, and really they are completely now thinking about zero emissions vehicles. A vast majority of that is of course battery, but of course there are hydrogen as well. I'm not going to get into the EV versus hydrogen debate today. What we are focused on is very much what the vehicle manufacturers are looking at for future, and that is EV. So we've developed an electric vehicle kit, just showing you a picture there. Again, all that information is in the app. I know I keep banging on about the app, but that's where we're going to keep sending you back. So what's addition to kind of the more standard Picoscope kits? Well, clearly safety is a big thing. So we've got our 2-pole tester, and this is so we can make sure that we've got 0 volts before we go anywhere near systems. And it goes without saying, nobody should be working in an electric vehicle any more than we should be working on normal vehicle systems without the correct and adequate training and whatever is required in your market. And then we've got our insulation tester, so clearly we need to be able to measure high voltages. And again, these are both a side of the scope actually, so what we're able to do is make sure that everything is completely safe before we start connecting Picoscope and testing with it. Then we've got our high voltage probe, so our differential probe, so we can go up to 1400 volts here. And we can do various tests, and like I said, we've now got guided tests within Picoscope 7 software. You'll notice that we have 3 current clamps, very simply, so we look at all 3 phases together on the EV. 3-phase systems are clearly a big part of how those vehicles are operating, so having 3 current clamps is for us the safest way to be able to capture those measurements. Then we've got 1000 volt backpinning probes, so they work much the same as a normal backpinning probe, but clearly they are Cat 2 rated. So again, we've got those. Then we've got a resistance lead, which does become important for EV testing. And I'm going to buzz through these because actually we've got a really great video that Ben's put together for us, showing us using it. Coil on plug probe, actually, so when we're looking at particularly charging systems, the charging coming into the vehicle, we use coil and plug probe for this all the time. So, not just for coil packs, actually it becomes a really, really useful and valuable tool in the EV kit, absolutely. Okay, so it's a very quick introduction to EV. New systems, we are part of it. You will see all of the guided tests in Picoscope 7 software. Ben's going to take you through a few tests now. He put these videos together for us. So we'll run that VT and then we'll have a quick tidy up at the end, and I'll try and have a look through some of those questions. Right, let's run that.
Hello there. So we're going to take a look at the 0 volt potential animation, and I'm just going to talk through the key points of the animation as well as the hardware, which is obviously our Pico 2-pole tester. So let's get started. So let's start the animation, and we start with our vehicle in the workshop, and we're just going to cut away to actually reveal the components underneath. Now we do have to make sure that the vehicle's switched off for this test, and if you're going through the guided test section on Picoscope 7, you will see this warning. We do have to accept this before actually getting into the guided test section for EVs. It's just there to make sure that you understand the dangers that are involved. Please make sure that you've had the appropriate training before carrying out any electric vehicle test. You do also need to make sure you have all the correct PPE, but that will be formed as part of your training. So the next part is obviously one of my most important parts of doing any sort of testing, especially with high voltage vehicles. Follow the vehicle manufacturer's technical information. They have all the answers and they've written them out in a set way because they want you to follow it. If you don't, you could be putting yourself at risk. So do make sure that you follow however they've mentioned, however they want you to do it. They've written them for a reason. Once you have your vehicle safely locked out, we need to test our device. Now the 2-pole tester is exactly that. It is a separate piece of hardware. It is designed to make it as simple and as easy to detect the absence of voltage or the presence of voltage. For this particular test, we're obviously looking for the absence before we can carry out any further testing. Prior to actually performing the test, we do need to make sure that the device is in good working order. To do so, a quick visual inspection will show up any defects, and the leads themselves actually have a wear indicator in them, so any chafing that potentially has happened to the device will show through as a white layer underneath. If that happens, please get that tested first before carrying out any physical live measurements. We also can check the leads for their integrity. By doing that, we need to depress the button on the front of the device. An LED will illuminate at the front, and then we need to touch the two terminals together. That will then illuminate, or should everything be okay, we should illuminate the LCD panel. All the segments will illuminate in red. There will be an audible sound, and we'll also see the battery level inside the device. So moving on, we need to obviously locate the test ports of the vehicle. And the first check is to make sure that the device can actually measure voltage. So take a known good voltage source. An easy one on any vehicle is the 12-volt battery. They will all have one. We will, or should have, majority of vehicle manufacturers will ask you to disconnect the 12-volt battery before performing any 0-volt potential check. Should we detect voltage, it will be illuminated on the screen. Now, if we're measuring a 12-volt battery, it will illuminate in blue to indicate a low voltage source. It will then illuminate, if there's any issue on high voltage, it will illuminate in red. So moving on, we will locate our test port. Now this will obviously vary between manufacturers. So make sure, again, another reason to make sure you read the technical information from the vehicle manufacturer. And in doing so, if there is an absence of voltage, nothing will illuminate on the screen. There's nothing there. Everything's safe. We are not detecting any presence of voltage. Just to make sure that there isn't a fluke or isn't been a problem between you moving from one point to the other, we then return back to the 12-volt battery in order to detect, to make sure that we can still detect a voltage with the tool. Happy that everything is okay? Then that is the end of the test. Hello there. We're going to take a look at the charging vehicle communication animation that's been put together to help assist with the guided test. Let's just give you an overview of how the connections are made and what's actually going on visually to help back up and support the documentation that's within the guided test. So let's take a look and run the animation. So as you can see, there are 3 different versions of the Type 2 connector up on the screen in the animation here. Reason being is that actually the only one we focus on is the domestic outlet Type 2 connector, or the slow charging Type 2 EVSE, and that's purely just to help us support the use of the CAT rated products that we have within the EV kit. So once you've established that we're using that type, then obviously we move on to the next part of the test. Obviously make sure before we're actually making the connections, the vehicle is disconnected from the charging source. If you're going into the guided test menu within Pico 7, you will have to accept and acknowledge this warning that comes up every time you go into the EV section on the guided test menu. It's just there to make sure that you fully understand what you're getting yourself into when you're going into electric vehicles, and always make sure that you have the adequate training in order to actually carry out the tests. Obviously within the training you'll be aware of the different types of PPE that are required in order to actually perform and diagnose systems on high voltage and electric vehicles. So once you've understood all that, you will click accept, and then it will carry on into the next part of the test where you can locate the Type 2 communication one. As with any of our tests, we always make sure and make you aware to use the manufacturer's data to make sure you can confirm the wiring, and that's in this case it's to make sure that we can trace and locate the CP circuit from the charge inlet down to the onboard charger. You may find that accessibility is easier at the onboard charger or at the vehicle inlet, but obviously make that assumption based on the technical information you've got from the vehicle manufacturer. Once you've established the actual route for that circuit, you can either trace it through. Here we've actually got in the animation an example of where this CP line goes to, and we actually found that the easiest path on this particular layout was at the onboard charger. So once we've located the CP circuit, we obviously need to set up our hardware. So we're going to use the differential probe. It's a cat-rated product, and obviously we're going to use the cat-rated backpinning probes that come with the EV kit. For this test, it's actually a low voltage circuit, so we can put the attenuation down to 20 to 1. And obviously when you actually switch the differential probe on, there is a power warning light there to indicate that the device is switched on. It does run on batteries, or there is a DC input on the side of the device, but if that light doesn't illuminate, then obviously make sure you've got power before carrying out any tests. Once you've connected, and obviously we can start the scope. Now, as soon as you connect the charger to, a powered up, so switched on EVSE charger from a domestic outlet, connect to the vehicle, we've actually got a trigger that forms part of the guided test. So the software will wait until that trigger is met before drawing and completing the guided test. So it gives you a bit of time if the charger isn't in the same location as the laptop to make sure that you never miss anything during this test. With the charger connected, you can see now that there is a voltage change. I'm just going to let this play on a little bit before describing the next part of what's going on. So here we have a signal that's coming in. So if we were to actually put the measurement rulers on, we'd have 9 volts positive, plus 9 volts, but a negative minus 12 volts. Now the reason being is that the EVSE will send out a square wave signal of approximately 1 kilohertz, and it will be a plus or minus 12 volt signal once it's made a connection to the vehicle. Now what happens at this point is that plus minus 12 volt PWM signal is going to now meet a resistor that's built into the actual onboard charger. That resistor is approximately 2.74 kiloohms. When that voltage of plus 12 volts passes through into the onboard charger, it also goes through a diode. Now this means that based on our position of the circuit, we are going to be able to see both sides of that signal, whereas the vehicle will actually only see the 0 to 9 volt signal. So just bear that in mind, that what you're seeing here is a combination of what's happening in the onboard charger as well as what's happening with the EVSE. Because of that 2.74 kiloohm resistor, it means a positive side of our signal will now drop to 9 volts. At this point, the vehicle is doing a number of different checks to make sure that what the signal it's seeing is okay. Within this signal as well, there's actually a duty cycle on that PWM, and that duty cycle dictates the amount of current that is available from the EVSE. It's not what the car is taking, it's what's available. So it may be that the car won't take all of the current that's available. It may want more, but it can't take any more than what's being delivered. Once everything's happy, then the vehicle will now shift its resistor path to now a slightly lower resistor of 1.3 kiloohms. Now the onboard charger has full control over this resistor. So it means that if at any point it isn't happy, it can switch that path off, meaning obviously electricity takes the lowest path of resistance. So if it sees that there's a 1.3 kiloohm resistor compared to a 2.74, it's going to go down that route. This will now mean that the voltage level changes, so instead of being 9 volts, it will drop to 6 volts. As I was saying before, if the vehicle sees at any point that it doesn't like something, such as the lock pin hasn't fully engaged, or if there's some temperature issues within the battery, it can switch this resistor off so that the path through is through the larger one at 9 volts. When it's at 6 volts, the vehicle is saying to the EVSE that it is okay and it's set to charge. Now at this point you may hear that the fans will start on the battery. You may also see that there's some lights that indicate charging's commenced on the dashboard as well. And here we can actually see the final waveform. Providing that everything's okay, then this will continue to go on and you'll see that charging will continue. But again, as I said, if there's any problems at the point the car isn't happy with something, that's voltage level, this stepped change will jump back up to the 9 volts to say to the charger, stop charging, I don't want anything more, there's something wrong. Alright, so I hope that helps. Thanks for watching. Hi there, so we're going to take a look at the motor resolver animation. and how the actual animation can help visualize parts of the guided test. So let's start the animation. And you can see here we have a plug-in hybrid electric vehicle, and it's being driven at the moment. Now, in order for the vehicle to know how to control the motor, it needs to know its precise position, which is what the resolver's job is doing. A couple of different ways that it can do this, but predominantly the resolver is the most convenient and the most, what's the word I'm looking for? Common, that's the one. Now, if you go through the guided test menu, you will see the danger of injury or death warning. Now, please accept that, providing you fully understand what you're doing. We do need to make sure that everybody's got the appropriate training when carrying out tasks on electric vehicles and anything to deal with high voltage. So this will also mean that you need the correct PPE, but you should all understand that, providing you've had the adequate training. So carrying on with the animation, now a key factor for this guided test is that you cannot use this you cannot complete this test using a common ground scope. So it's only for the newer 4425 and 4425A picoscopes. The older 4423 and the 8-channel 4823 scope are not, you cannot carry out this test. We rely on the floating input aspect of these scopes in order to carry out this test. So continuing on, obviously make the connection based on ease and accessibility and following the diagrams within the technical information, and start the vehicle. Now, it may be that you have to physically drive this vehicle out on the road, so making sure you've got good connections is important. There are other ways where you may be able to get the signal to change if you jack one wheel up and spin the wheel. But obviously do make sure and take all care and consideration if you are driving out on the road and capturing data. Most best advice is to take somebody with you in order to control the software whilst you're paying attention to the road. So we'll carry on with the animation and we'll get the waveform on the screen. And as you can see, we've got our pattern. Now, there is more information within the guided test about what this pattern means and how it's interpreted. But yeah, it's all written in there, and I'll leave you to go and digest that in your own time. All right, thanks for watching.
Excellent, and thanks to Ben there for putting those together. Ben's working from home, like a lot of us still are actually here in the UK, because clearly coronavirus is running amok. Yeah, as I said right at the beginning, I've just recovered from it. I was double jabbed, but I think, unlucky to catch it right. So I was about 5 months after my second dose. So I think you are losing, certainly, yeah, you're losing certain amount of immunity. But lots of people I know are double jabbed, and it's still kind of moving around amongst us. So yeah, we're not over this yet, I'm sad to say. But what I would say, being double jabbed, I was wiped out for 2 weeks, but I never thought I would be in hospital. That's probably the easiest way I can do it, because anyway, nobody really wants to know about that. Right, so back to EV. All those guided tests, they're only in Picoscope 7, the electric vehicle guided tests. And just one thing to note, hidden in the top of each guided test, there are some links to videos. They are not on YouTube. The only way you can get into those videos is through the guided test. So if you're interested in working on electric vehicles and how you deploy Pico to various EV components, go in there, and Steve and Ben have put together videos live here in the workshop working on components. So check those out, please do. Right, just a very quick recap. We're coming to the end now. And understanding waveforms. So, as we keep saying, look at the guided tests. There's loads of information there to help you. Working with the waveform library. So, you know, finding a good known waveform from the vehicle you're working on, and also make sure as technicians you're saving your own waveforms on the waveform library. The bigger this becomes, the more waveforms we get on, the better it is for everybody. This is a real community effort, building that waveform and that database. So we really do appreciate you trying to upload your own waveforms and remember, If you upload your waveforms, put all the information on, we're storing them for you for free. So actually you have on, when you log in, you can just look at your own waveform. So, you know, if you drop your laptop, you're not going to lose everything. We do look after that for you on the cloud. And of course, having access to good technical data and service bulletins can be a real help to you as technicians to getting good diagnosis as quickly as possible. And that's what it's all about. And of course, generally building your knowledge, you know, videos, go on our YouTube channel, case studies, on our website, on our monthly newsletter. If you're not signed up to our monthly newsletter, please do. Forum as well, so you know you're going to become a member of the forum to look at the waveform library, to use that. And again, face-to-face training. You know, hopefully we can do a lot online, but you know, when we're able to get out there and you know, start learning practically about using and applying Picoscope. And of course the app now gives you a huge amount of help. There's a whole series of videos in the back of the app under training that take you through the very basics right the way through to capturing more complicated tests. So a little bit about help and support. Of course, please, in the first instance, contact your local distributor. They are there to help you and support you locally and of course in your own time zone. But you can find information on our website, so that's www.picoauto.com. Don't get caught out and put Picoscope into Google or any other search engine, because sometimes you'll get to Picotech, which is our sister company that deals with oscilloscope for the electronics industry. You want Pico Automotive, and that's us. And YouTube, you know, we're live streaming you today on YouTube. It's a great source for us. This link, as I've said a couple of times, this link will remain open, so you're welcome to go back and review this again. But there's a huge amount of videos on our YouTube channel, just about on every subject. There's been quite a few questions that have come through on that chat. The answers to most of those will be on the YouTube as well as other locations. So like I said, we'll be firing through to the distributors answers to those questions and links to where you can go and find more information. So get in contact with them and they'll be happy to pass those on. Yeah, and you can contact us direct if you want. If you've got issues with software, like we've had this morning, like I said, you can actually put software issues directly into the feedback form on the software. It goes right through to the team. Nothing gets in the way then. So it's a really good way of getting through to the forum. Okay, we're nearly there. So finally, a message from Pico Planet. So I'm sure everybody's aware climate change is becoming a bigger issue around the world as we see more extreme weather events. We're in a real pickle here, and EV of course is part of the solution, but we're going to have to look at everything. I'm only going to leave one thought actually. You'll all have been aware that COP was in Glasgow this year, and you can download the outcomes of COP from Glasgow, which is of course where we should be agreeing how we solve this crisis, and I think we can only call it a crisis now. There are 2 lines in the COP agreement in Glasgow that are literally only 2 bits, but I think it's line 26 and 28, but you can view it online. The first one is that COP recognises that we need 45% reduction in global greenhouse gas emissions by 2030. That is only 8 years. We need 45% reduction to make sure we stay within safe boundaries for our whole planet, which sounds a bit mad. 2 lines down, with all the agreements that were agreed in COP in Glasgow, they are estimating that by 2030 we will have a 13% growth in greenhouse gas emissions. So there is a huge disparity in terms of what we're agreeing to and what needs to be done, and the longer we leave it, the worse it becomes. Anyway, the premise behind all of that is, as a business, we're doing everything that we can, and I think we all have a responsibility to try and do everything that we can. So we have a range of targets, and we will be net zero carbon by next year. So we are reducing everything that we do. We'll be zero to landfill. We're reducing business travel. We're not flying like we were. and that's a huge, so that was our biggest carbon emission. We were something like 500 tons of carbon just from flying around the world, so we've cut that down to sort of 25%. We are going to have to do some, of course, but we are going to reduce it. We've done a lot of work here during lockdown in terms of super insulating our buildings, so we're using less energy for the buildings that we run and operating. Clearly, COVID gave us hybrid working, so we will continue to work from home, roughly 50-50, and that's across the business. Of course, the guys who work in the warehouse are putting our kits together all the time, have to be here all the time, but those of us who can work from home will continue to do so moving forward. And like we say, no greenwashing. Everything that we do within Pico, we will put it all. There's going to be a new page on our website which will launch early in the new year, and that will take you through all of our emissions in terms of our footprint going backwards, and then what our plans are forward, and then how we're moving forward on that. And then we will offset to begin with, but offset's only half of it. Like I said, what we're looking for is a 50% carbon reduction by the end of this. By the end of this decade, by 2030, we need to reduce our carbon usage by 50%, because that's what the science says we need to do. So that's what we're going to do as part of our company's commitment to helping to solve. I don't like that word. I don't think we can solve it. I think we've got to just try and really work together to do more than we're doing already. So that's it. That's it from us. Where are we? What are we doing, Tom? Oh, about an hour. Yeah, sorry, 2.5 hours. Are there any further questions? Maths channels. What we're going to do, actually. I'm going on holiday tomorrow, so I'm going to leave Phil, who's going to be in charge. We'll copy all of the questions, actually, and like I said, we'll get them all answered for you guys. We'll send them through to distributors, drop them an email, and they'll be more than happy to share with you all of our answers and all the links. So I think that's it. 2.5 hours. I hope you found that interesting. I know we start off quite slow, but we kind of want to make sure we bring everybody along. And in the second half, hopefully we started to dabble into some more complicated areas. We do plan more for the new year in terms of videos around case studies particularly, so we can look at applying Picoscope to issues you will see every day within the workshop. So make sure you subscribe to our YouTube channel for those. We're not doing Pico Academy like this. In the spring, we're going to be doing an off-highway version. So for any of you out there who do work on off-highway, be that agricultural or on plant, we're going to be doing a whole session on that in the spring. More to follow. Keep in contact with the distributors around that. We'll be sending links into the new year. I think that's it. So from myself and Phil, where are you, Phil? Step sideways. We can only see your arm, man. There he is. There he is.
Nice to see you guys.
So yeah, thanks for coming. Thanks for watching. Link will stay up for a good few weeks, so you're welcome to come back. And any questions, just let us know. Cheers, guys. Oh, I've just dropped. Oh, sorry, I've just knocked Phil out.